So this video is actually on the chapter 12 homework 3. The first one that I had recorded was actually on classwork 3. It was on solving the trig equations worksheet number 3. That was classwork 3. So this one is classwork homework 4. Even though it says 2 on the paper, this is our 4. So for each of the following equations, what are the solutions that lie in the domain 0 to 2 pi? So including 0, but this means we're not including 2 pi. So we're going to go up to 2 pi, but 2 pi will not be included. Okay, so we don't on this one have to do the plus or minus 2 pi n. We're just going to list every one within 0 to 2 pi, but not including 2 pi. Okay, so when I am solving this, I'm going to have 2 sine x is equal to 1. I'm going to divide by 2, so I get sine x is equal to 1/2. So I'm looking for a positive sign. Positive sign. Sign is your y, so that means we're going to be in quadrants 1 and 2. This is where I'm looking. And you have to remember that 1/2 is your short, root 3/2 is your long, okay? So I want my y to be short. So I want long comma short. So I'm going to be here, which is at pi 6. And then I'm going to be here at the other side, which is going to be 1 short of pi, or 1 short of 6 pi 6, which is going to be 5 pi 6. So my answers are going to be pi 6 and 5 pi 6. Those are my 2 answers. Okay, on letter B. So for this one, I am going to divide by 2. So I'm going to get cosine x is equal to negative root 3 over 2. So this is a long. And when I'm looking at this, I want where my cosine is negative. Cosine is your x, and your x is negative on this side, over here. So it's going to be quadrant 2 and quadrant 3 is going to be cosine, which is your x, is going to be negative. And then we're looking for a long for my x. So this is going to be long comma. So this again is long, and that is our x because it's our cosine. So let me just say this one more time. This is long. So that is our x, which is our cosine. So I'm going to go long comma short. So I'm going to be here, and long comma short. So I'm going to be here. And so these are pi 6. This right here would be pi, or 6 pi 6, which means that these answers are going to be 5 pi 6 and let's see, 7 pi 6. And those are going to be your answers. So 5 pi 6 and 7 pi 6. And again, we don't need to do the plus or minus 2 pi n or anything because we're going from 0 to 2 pi, but not including 2 pi. Okay, on letter C. Okay, we're going to divide both sides by 2. So I'm going to get sine x is equal to root 2 over 2. This is a positive sign. So positive sign means I am going to be, because that's your y, in these 2 top quadrants, quadrant 1 and 2. And so I want my root 2 halves. That's going to be at pi 4ths. Because that's root 2 halves, and over here this is negative root 2 halves, but positive root 2 halves for your y, and that's going to be 3 pi 4ths. And so that's going to be your answers, pi 4ths and 3 pi fourths. Those are your answers. On D, I don't know why I didn't put a little unit circle here for you. Let's add one in. Okay, so I want where my cosine is equal to 1. And so cosine is my x. So I want my x to be 1, and that happens to be here at 0. It's 0 and 2 pi, but they wanted us to go up to 2 pi, but not including 2 pi. So this answer is 0. That is your answer. 2 pi's also, but again, they didn't want us to include it. Now, the next sections are review. Okay, this is review of our systems of equations, 3 equations with 3 variables. Now, you'll notice that this is the only one with a z. I cannot eliminate my z. That's just not going to be a situation I can do because there's no other z's. So that means I'm going to try to deal with these 2 right here and solve this system. So I either can get rid of my x's by trying to make the top one a -2 while the bottom one is a +2, or I can get rid of my y's by making this a 2, since that would make, and when I say a 2, it's actually going to be a -2 by times by 2. And then I don't have to change my sign, so I think I'm going to multiply the bottom one by 2. So I'm going to multiply this one by 2, which is going to give me a 4x minus 2y equals -14. And the top one I'm going to keep as is, x plus 2y equals 4, not doing anything to it. So I'm going to solve the system, including x and y. Okay, my y's are going to cancel out. I'm going to get 5x is equal to -10. I divide by 5 and I get x is equal to -2. So that's my x. I still have to find my y. So I'm going to go and plug this into one of these 2 equations that I have in that baby blue box. I'm leaning towards the bottom one, but it really doesn't matter. So let's say I'm going to do it into this one right here. So I'm going to go 2 times -2 minus y equals a -7. So I'm going to get -4. I'm going to actually add my 7, and I'm going to add my y. And so I get my y is going to be 3. Okay. Now that I have both of these, I can actually find my z by plugging into this equation. So now I'm going to use this equation. I'm going to put -2 in for my x. I'm going to put 3 in for my y, plus z is equal to -4. So I get 1 plus z is equal to -4. I'm going to minus 1, so I get z is equal to -5. And that's my z. And then we have to give our answer in as a point. So my answer is going to be -2, comma 3, comma -5. Always your x, your y, and your z. The next set of problems are dealing with logarithms, okay? The first one dealing with natural logarithm. Just a little reminder, if you have an ln of x, that is a log base e. E is like pi. It is an irrational number. It's on your calculator. It's actually on the ln button. If you do second and ln, you're going to get that. But it's just a regular log. We do the same thing. So when they say condense, they want us to write it basically as a single logarithm. So what happens here when I'm doing this, anytime I have a number in front of a log, that number is going to be the exponent of what I'm taking the log to, log of. So since I'm taking the natural log of x, that 3 in front is going to become the exponent, okay? And I'm going to do the same thing here. Here, this is going to become the exponent, which is going to be ln of 2 to the 4th, and I'm going to do that math in a second. Minus, and then here, again, that's going to become the exponent, so I'm going to get ln of y squared. So I'm going to have ln of x to the 3rd plus And ln of 2 to the 4th is 16. So it's going to be ln of 16 minus ln of y squared. So now, when I have ln's, natural logs, all at the same base, okay, because that's what natural logs are, they're all base e. I can write this as a single logarithm. Anytime I have a plus, it's going to be multiplying on top. Anytime I have a minus, it's going to be on the bottom. We're dividing by it, okay? So this is going to become the natural log of, and I'm going to have x to the 3 on top and my 16. So I'm going to write it like this. 16x to the 3rd, and then minus the ln of y squared. So the y squared is going to be on bottom. And that is our answer. I think we're going the other way on part B. So this time we want to expand. So when we're doing this ln, this 3 here, a couple ways I can do it. I can have that 3 come to the front of this. That's one way to think about it. Or I can have both of these raised to the 3rd power. So this is really x minus 3 to the 3rd and 3x plus 2 to the 3rd. And then when I have the natural log of a product, what I can do is when I have this times this, then I can write 2 separate logarithms, ln of x minus 3 to the 3rd, plus, because they're multiplying, ln of 3x plus 2 to the 3rd. And then the last thing I'm going to do is I'm going to deal with this. Let me make this a little skinnier. I'm going to deal with this exponent. And this exponent is going to move in front. Okay. So this is going to be 3 ln of x minus 3 plus 3 ln of 3x plus 2. And that's our answer. Now, just a quick note. Again, I said I could have put that 3 in front. So I could have put that 3 in front automatically like this. Okay. And moving that to the very, very front. Okay. Then I'm going to have 3 ln of x minus 3 plus 3 ln of 3x plus 2. You could have also done that, and you see I get the same answer. Okay. And this is a review of our geometric and arithmetic sequences. Here we're dealing, our series, we're dealing with geometric here. My r is equal to a 1/2. I'm timesing by 1/2. And so if my r in absolute value is between 0 and 1, my infinite sum does exist. And the formula for that is s is equal to 1 over 1 minus r. So I am going to have s is equal to 1 over 1 minus 1/2. So that's 1 over 1/2. And that is going to be, sorry, it's a1 over. I forgot my a1. I apologize. a1 over 1 minus r. Okay. So a1, always your first term. Okay. Always your first term. And so my first term is 6. So I'm going to have 6 on top. And then I have 6 divided by 1/2, which is the same as 6 times the reciprocal. And so I get 12. 12 as my sum. So I'm going to use that same formula with the a1 on top over here. And so my r is 1/3 because it's whatever's being raised to the power. And if I want to find my a1, I'm going to put 1 in. And when I raise this to the first power, I get 1/3. So my S is going to be 1/3 over 1 minus 1/3. So that's going to be 1/3 over 2/3. And that is going to be 1/3 times the reciprocal of 3 over 2. Those cancel out. And I get 1/2. And that's our answer. So hopefully this helps you guys.